stuff out there that is pure bull, okay? Because people extrapolate. And there's a cartoon I'd love to show. And I don't have the cartoon right now, so I'm going to tell you what it is, okay? The cartoon is labeled, I think, therefore I scan. Now you remember Kant's comment, I think, therefore I am, okay? And so it's a picture of the phrenologist who went and felt the bumps on people's heads and used to predict what their personalities were like based on the bumps on their heads. And then there's an image, because so much of this is based on what we call functional magnetic resonance imaging. And what's so cool is there's a picture of a neuron on a treadmill. So the neuron is on the treadmill. Now, do we measure the activity of neurons in functional magnetic resonance imaging? Only indirectly. And this indirectly is where a lot of problems reside. This is the indirect. When a neuron is exercising itself, meaning it's active, it uses more oxygen, and since neurons store nothing, they have to take what they need from the bloodstream moment by moment. When they take the oxygen that the hemoglobin carries, the magnetic character of the hemoglobin changes, and that gives the signal. So here is the thing. The supposition is made when a neuron is active, it uses more oxygen, it takes it out of the hemoglobin. The hemoglobin without oxygen has a different magnetic signal. The problem is that's only when the activity is new. If you're exercising a neural circuit that has been well developed, it utilizes minimal energy and it shows nothing on the functional MRI. So you think the brain's not active. One of the things the brain is very good at doing is efficient. And it's going to use the least possible energy necessary. And that means going back to past experiences. So part of why change is so hard is that neural circuits that are developed take very little energy. It's like once this room is wired, all you do is switch the light switch on and all the lights come on. When you're developing a new neural circuit, you have to wire that light to this light, that light to this light. That's when you see the activity, when it's new. But the supposition has been made that when you see the activity, it means the brain is active. And when you don't see the activity, it means the brain's inactive, and that's absolutely false.